Hello, Year 11s. This is the night before news for engineering. This slide shows you all the topics that will be involved in the paper that you'll be sitting tomorrow. We've had practice and revision on these topics, and they've also been on ABBA since before half term. You are completing a Unit 3. Previously, you've been doing Unit 1, which was the making of a maintenance rig, and Unit 2 was the redesigning of the bike maintenance rig, and now Unit 3 is the written paper. It is 1 hour 30 minutes long, and it's out of 80 marks. It's important that in this paper you attempt every one of these questions and you answer as fully as you can using complete sentences. If you finish early, go through the paper again and check if you've answered every one of those questions. Now, two things really that it could help you with. When you go back through your paper, it might be that you've missed a question without noticing that you did, but also it might be that for any questions that you wasn't sure of, as you go through answering the paper, going into the paper, there could be some questions that actually help you or they trigger your mind and allow you or help you to go back into that question that you missed, that you wasn't sure of, and answer it. Okay, so it's very, very important that you attempt every one of those questions and go back through the paper again to just double check and make sure the answers are correct, in full really. How to answer the questions. In this paper, there will be times where you'll be required to state reasons or to state an idea. Now, these questions are normally a 1 mark question and only require you to write in one sentence to be able to achieve that mark. Now, some of the questions here might require you to describe or discuss either a process or advantages and disadvantages. Now, these questions are normally 2 mark questions or more. Okay, they go up to about 6 marks at times. And here you are required to extend and explain your answers. So, for example, if a question is out of 2 marks, you might be required to give an opinion and then from there have an example also written to be able to achieve 2 marks. So 1 mark would be for explaining that concept, and then another mark would be for giving an example, and that's how you then receive or achieve the 2 marks allocated to that question. Okay, some of the questions on here might require you to use notes and sketches. Now, when you use notes and sketches here, they're normally 4 marks to 10, up to 10 marks questions. And what you're required to do here is to combine sketches and notes to be able to achieve those top marks. Now, it might be that when you answer this question, you might decide to sketch first. So do your drawing, and then after that you might want to label that drawing and use some notes to explain what's happening within that drawing. I will go through this in a little bit more details in the next slides. Now, in question 1, you'll be asked questions to state the different, what is, list some, or identify. And these are the topics that will be included within that question 1. The first one is alloys. What are alloys? Alloys are a mixture of 2 or more metals. And why are metals alloyed? Metals are alloyed to improve their properties. Now, when we talk about properties of alloys, we know they are much better than pure metals because they are stronger and harder. They're much more durable. We know they're easy to shape, which we call being malleable, but also they are corrosion resistant. They do not rust as easy as pure metals will. Okay, some of the examples of alloys we spoke about, we said about brass, we've spoke about stainless steel, which we see used in cutlery at home, so stainless steel, but also things like bronze we've spoke about as an alloy. Okay, now the next one we're going to be looking at is testing products. Now, extensive testing is part of the engineering process, and it has to be done to estimate the durability of machines really, and the materials and the components used in an engineering product. So the testing can be done either destructively or in a non-destructive manner. Okay, and we know when it's been destructive, the materials are tested until they get damaged. Whereas a non-destructive testing, the material doesn't get damaged or the product doesn't get damaged. Now, some of these examples of non-destructive testing, we spoke about things like visual testing, where you're just looking at the product to check and see if it is what you wanted it to be, but also just simple as turning a product on and off. It's a way of testing without destroying it. But if you are going to destroy it, you might want to use pressure. So we could have pressure testing until that material or that component gets destroyed or breaks. Okay, and that's about a destructive and non-destructive. We've gone through this topic in length. If you need any sort of clarification on it, please go onto your OneDrive, Student Drive. There is plenty of information there that we've used previously as we discussed these topics. The next one we're going to look at is surface finishing. Now, here we're only looking at finishes that we use on metals, no other materials. I don't want people in this instance to start looking at timber, because we haven't really used much of timber. We've been focusing a lot on metal. So when you asked about finishing techniques, you're looking at the ones that you could use on metals. And the simplest ones, or the closest ones we can think about, is painting. It's the the common one that we know of. We can polish metal. If you think about it, trophies and trumpets and musical instruments, you'd polish them to finish. But also we could chrome plate, we could powder coat, we could do things like gold plating. That's another one that's used in a jewelry. So gold plating can be another one that you could mention in that list. Okay, so that's about surface finishes. Now the next one to look at is about materials, composite materials, really. And they might ask you a question based on carbon fiber. Now, a common question that comes up is, name a composite material used in Formula One car racing, and your answer could quite easily be carbon fiber. And now the next question would be, explain why this material is used. We know carbon fiber, it is 10 times stronger than normal steel, but also it's light in weight, which is why it will be used for those fast Formula One cars. What we then say, a technical term really to explain this, we say it's got a good strength to weight ratio. This is what we've been talking about really in engineering. Good strength to weight ratio compared to normal steel that could be used, or alloys that could be used in a Formula One car racing. And again, when you look at this, really always be looking at the marks allocated to the questions to help you decide how much information you put in that to answer that question. So question 2 is about application of knowledge and skill. Again, we're going to be looking at materials and their properties, but this time, rather than looking at alloys, we're going to be focusing on a ferrous metal, and one that you've been using a lot, that ferrous metal, is a mild steel. Now you will be asked questions relating to mild steel and properties of mild steel. What makes mild steel a better material to use for the products we've been making in engineering? I'm not going to go too much into these details, as you've got all this information in your PPE help sheets in your student drive. Now I'm going to move quite swiftly onto tools and machinery. Now, one here that we've attempted to use, and a lot of you were interested a lot in it, is this metal lathe. Sorry, I've just used yellow here. I should have used black really. Now, metal lathe is a machine that we use for making any cylindrical metal and turning it into different shapes. Now, these are the parts of a lathe machine. We know of the guards, the emergency stop and start buttons, the variable speed controls. But the most important parts which we used, or we tried to learn last time, is this section here, which we use for making holes on the thumbnails, but also knowing the tool post is the section where we're using to clamp our tools onto it. So cutting tools, nailing tools, and so forth. This is where we clamp all those tools. But also again here, the 3-jaw chuck here, which is where we hold our material when we turn it. Now this here, together with the saddles, are what we attempted to use and make successful products. I forgot the cross slide here as well. Okay, so knowing these 4 or 5 components of your metal lathe would help you very much in your exam to be able to answer the questions about this machine here. But now when we look at the chuck, we know another piece of equipment which we used is the bench drill. And when you look at a bench drill, we do have a chuck also in this area here. Okay, so a chuck is seen in a lot of our equipment that we use. So on a bench drill, as I said, on the metal lathe, and on a CNC machine, which we are going to start using very, very soon. Okay, so a chuck is a very good, rather not good, but it's a component or a piece of those equipment that we use a lot to hold our materials when we work on them. Now, some questions that may come up might be identifying some of the tools that you use when you are working on a lathe machine. Okay, which tools do you assemble or attach onto your tool post when you're working with the lathe machine? Now, a few that we've used previously, we've used a nailing tool. We've also used a rod tool. And nailing, as we remember, we used it to create texture on our material. Okay, a rod tool, we just used it to turn material to make it smaller. So it could have been from about 16 millimeters. We turned it down to about 8 millimeters in some of the projects we've worked on. So a nailing tool, the rod tool, parting tool, which is at the bottom here, it's used if you need to cut off your material in these sections, mainly where you're trying to cut your material in half. You'll use a parting tool. But another one that we haven't attempted to use just yet, it's a threading tool, and we will get to that later on. So rather than using a tap and die set on the lathe, you could attach a threading tool onto your tool post to create threads on your material, and we will be attempting to use this later on as we progress in engineering. So this is mainly about the tools and machinery. I'm just going to move on to the next slide to do processes and sectional drawings. Sectional drawing is part of design or engineering communication. Okay, this is a way that we use to communicate our drawings in engineering. Now, a lot of the times you'll be given an isometric drawing, and with this isometric drawing, it's a 3D shape, and then what you're then going to be given is a top view of that item or that product. Okay, and then the top item, what you'll be shown is these lines here called a section line. Now a section line, it's a way that shows us where a material has been cut. So a section view, really what you'll be required here is to show where an object has been divided into two. So you can see on this example here where it shows that section line being drawn, and it shows where the section line is going through on that piece of material or that piece of item or equipment or that artifact. Okay, now as an engineer, you'd then be required to draw a sectional view of this component, and a sectional view, really, you're supposed to demonstrate or show where a piece has been cut. So in this instance, when you're required to do this, you can use this as an example, really, and what you'll be seeing is this shape here, and this is what you'll be required to draw onto your to answer this. Okay, and as an example, I'll just show you very quickly how this would come up, how you'll draw it. And this is showing this area of your component. Now to show or demonstrate or show where the line has a saw blade has gone through, we used lines to shade off the area where we know the blade would have gone through. In this case, you can see in this example, it's been shown here as well. Okay, so in your component or in your answer, you'll be required to show this highlighting. But one area we've missed is this section here, and we've missed it deliberately because if you have a look onto your component, we can see it shows us there's a hole in this area here. Okay, there's a hole there. So if you are cutting this component using a saw, the blade will not go through a hole. Hence why we then leave it, because we know there's no blade that's going to go past in this area here. It will only cut through the material in this section. Okay. So in question 2 again, you'll be asked to describe a process. Okay, so we can see in this question here, it says describe the process of. Now the processes that you could be asked about, it could be about cutting a thread. Now a thread could either be an internal thread or external thread. We've all done these processes about cutting a thread, but also it could just be that you're asked to talk about a drilling process, and we've all used drills in engineering. So it could be based on any processes really that you've completed or done in engineering. Now the other thing here, it says use or add sketches to support your description. Now when we look at the marks allocated to this, it's an 8-mark question. So for me, if I was me, or what I would encourage you to do is to use or get some marks from your sketching or your diagram, add some notes to explain that process, and that might get you about 3 marks, but also explain or name the tools that you're going to use in this process for the other remaining marks. So I would be sketching, which is on the diagram being shown here. Naming the tools, I could talk about tools like the vise, which is already mentioned, but also I could talk about the die wrench, which I will be using. I could also name the die which is in the middle, and I might even specify the measurement for that die. Okay, this 3 could then gain me about 3 marks because I have named tools I'm going to use. Okay, so the next thing I'll be doing is then explain the process of doing this. Okay, so I could talk about then place a metal bar in a vise. Again, I've included a vise and what material I'll be using. Select the correct die size and the die holder. Again, I've included the tools there, but the size, as I've specified previously, which would be 8 millimeters if it's an 8 millimeter bar. Add a cutting compound. Now, a cutting compound we've used here is Trefilox. You don't need to know the name of it, but as long as you've explained there to include a cutting compound, sorry, to reduce friction, then you would be awarded the mark for including that point. But also placing the die or the bar straight level onto the vise, because what you're trying to achieve here is a straight 90 degrees here, so that you can actually cut a clean thread at the top there. Okay, but also the process, how are you going to achieve that process? So once you've placed your bar into a vise and you've inserted the die, then turn carefully in a clockwise direction until the thread starts to cut. That's what you'll be doing in this process, and then gently turn anti-clockwise to deburr it. Okay, we know we've done this process so many times, so including all of these steps, as you can see where I've given a tick, every one of the steps you're writing would give you a mark for explaining that process. So that's in a nutshell how to answer a process. You've got a diagram, and then you've got notes around it to support and and explain to the moderator or the person marking your work, you understand how that process works. And with all of these, you're definitely and would be guaranteed to achieve and get your 8 marks straight away. Okay, now the next question you're going to be required to answer in this section is about Ohm's law, and we use these diagrams to help us be able to calculate for either resistance, voltage, or current. Okay, and we know in this section, for calculating voltage, we are going to multiply current and the resistance. But to calculate resistance and current, you will use a division, which this line represents. It's a division line here. So you divide voltage over current, or either voltage over resistance. So just in a nutshell, we know this here represents division, and then this line here represents multiplication. Okay, in this example you've been given on the side, if you was to calculate voltage, we know you multiply current over resistance. If you was asked to calculate current, you will divide voltage over the current, and if you are asked to calculate the resistance, you then divide voltage over the current. So I've just given you some examples here which I'd like you to attempt. So pause the video. I will also stop for 3 seconds, and I will then carry on once you've attempted to answer this question. So in this question, you're required to calculate the voltage. You've already been given the resistance and the current in amps. So the way you'd answer this question is voltage equals to current multiplied by resistance. So we know current already. We've been given as 250 amps multiplied by the resistance, which is 25 ohms. So to do this, it's as simple as multiplication. It's 250 multiplied by 25, and you will get 6,250 volts. And that's how you'd answer this question. Number 2, what is the current produced by voltage of 250 volts through a resistance of 0.2 ohms? We've already now been given the voltage and the resistance, so we know straight away we need to be calculating the current. So to calculate current is equals to voltage divided by resistance. So current in this case would be voltage of 240 volts divided by a resistance of 0.2 ohms. So current therefore would be 1200 amps. Okay, and that's how we'd answer these questions here. If you need any more help on this or any other questions that you might want to attempt, again, is on the PPE revision in your student drive. There's some more questions there that you can use to practice how to calculate current, voltage, and resistance.